I'm gonna explain to you one of the most important concepts to understand if you want to get into the hobby of building your own custom electronics projects. And that's the three main types of motors you have to choose from if you need one for your project. Starting off with one of the most simple styles of motor, this is called the DC motor. These are super simple. The more voltage you apply, the faster the motor spins. And if you switch the polarity, so if you hook up positive this side and negative this side, it'll spin the opposite direction. These are really popular because they're super affordable and very reliable because of how simple they are, but they do come with one major downfall. That is that it has no positional awareness. You're basically blindly injecting voltage into this thing and making a rough estimation on how fast it's spinning. But if you need the motor to spin up to a really specific speed or go to a really specific position, you can't really do it with a DC motor. And that's where the servo motor comes in. You can usually identify these by having 3 wires coming off them. Now, interestingly enough, the servo motor actually has a DC motor built into it. That's where 2 of these wires are going. But there's one more component in there, and that's this. This is called an encoder. An encoder is a really simple electronics component that you could turn, and it will output a signal on one of these pins for exactly which degree it's turned at. You'll really recognize these from like volume knobs or anything like that. They're really popular. Now, inside the stepper, there's basically a DC motor with this encoder attached to it, so it knows exactly what angle that the motor is rotated to. So if you want to turn the motor to a really specific position, it's going to rotate a little bit, check what position it's at. If it's not there yet, it's going to rotate a little bit more. If it overshoots, it's going to rotate a little bit backwards. It's done this like thousands of times a second, and it becomes a really accurate motor for honestly a really low cost. These things are very affordable. Servos are what I use for my mechanical clock display here. Basically, these gears have certain positions that are mapped to different sections on the encoder, so it always knows exactly what position to turn to show a given number. One major downside of most servos is because they require this encoder that has a top and bottom, you could only spin it so far. These things don't have a full constant 360-degree range of motion. They can't just keep spinning. Usually they only have 180 degrees, so they're only good for spinning kind of like small directions. There are some very specific servos that can do more than this, but almost all servos will be very limited with their range of motion. Now, if you need full range of motion and super accurate and precise, that's where one of these babies comes in. This is a stepper motor. Steppers are really popular on things like 3D printers, and they come in all sorts of different shapes and sizes. The easiest way to identify them is just by having a whole bunch of pins. They have super precise control of exactly where they're at all times. I won't go into too much detail about this, but they basically have little gears on the inside that are called steps that are magnetized, and it can basically switch that electromagnet to exactly whatever step it needs to be. Do that in a super controlled fashion with really high torque. 2 main downsides to steppers though. One is the cost. These are usually going to be 10, 20 times more than any of your other alternatives, and they don't retain positional awareness when they lose power like a servo does. So because a stepper motor can rotate 10,000 times if it wanted to, it has no way to know exactly where it is as far as how many rotations it's gone unless it stores that data in a computer's memory. Unlike the servo, where if it loses power, it has an actual piece of hardware inside it that's physically set to the position where it was at before, with the stepper motor, if you were to lose power, this thing would have to pretty much totally reset. That's why you'll see on devices like 3D printers, there's usually something called a homing switch, where the stepper motor will go and push that switch so it has full awareness of exactly where it is in positional space. I went a little bit deeper than I was planning there, but I hope that was somewhat useful because motors are a lot to navigate. Usually there's not one size fits all option, but you're probably going to find yourself using steppers and servos pretty frequently for most of your projects. If you have any other questions, let me know. Thanks for watching.